Hello and welcome to Accounting Information Systems. I am your host, Dr. B, and today I'd like to talk about software and systems. Throughout this conversation, we're going to talk about how to summarize characteristics and components of information systems, identify the technologies used, explain how growing a business enhances these systems, and describe the features and the implementation considerations for ERP. So first, it's important to understand the different types of information systems. And the first two systems I'd like to talk about are transaction processing and online analytical processing. When it comes to transaction processing, we are looking at how the system supports the core business functions, such as sales, accounting, purchasing, and other functions. In thinking about online transaction processing, I want you to think about the last time that you purchased something online. For example, I recently went onto Amazon and made a purchase. What happened in the back end of that purchase? Since it's online, from the Amazon side, the sale, the accounting, and the purchase all happened at once from that transaction because of the automation that Amazon uses, of course. In the other type of information system, the online analytical processing, the system focuses on leveraging data for information. An example of this would be Amazon sold this product 1,000 times over the last month. So Amazon can forecast the number of purchases of that product that they need to make in the future based off of that number of sales from last month. So here you can see the use of data informing the future purchases. So this will be an online analytical process. When it comes to the online transactions, we look at things like what's being processed in the transaction, how it is used in modifying the database by adding and changing the transaction data. We know that the online transaction process happens in real time. And then from an online analytical process perspective, we can see how the process reports and analytics work based on the queries for the database. They answer the questions. And this also happens in real time. So think about these as being two separate systems. It's important to understand that there are different levels to these types of systems. And it really depends on the level of detail that individuals within the company are looking at. So, for example, the first type of level of an information system we see here is the executive support system. Just as the name implies, the idea here is to support strategic decision making using a data subset in order to support these decision making processes. The second one here is a decision support system. And in this, we're looking to solve a non-routine problem using unstructured decision-making data. The third level is management information systems. We're using data to assist management in making routine management activity type of decisions. And then, of course, we see the transaction processing system that we talked about earlier from the perspective of processing day-to-day business activities to provide a foundation of other systems, and of course to capture data that's fed through the higher level systems. Of course, that transaction data that we use on a minute by minute, second by second basis, real time, it helps to inform the other levels, right? So think about the transaction processing system as being the base of information that helps to inform management information systems, that helps to inform decision support systems, that ultimately helps to inform the executive support systems. So think of it from that perspective, transaction processing systems being the base to support and inform the different levels. And here we can see a nice infographic of that type of information. We see the transaction process systems supporting the upper levels of management. So this infographic really helps to really put everything together. That shows us how the transaction processing system supports management information systems, that supports decision support systems, and then of course supports the executive support systems. When we look at transaction processing, as I had mentioned, it's real-time information. It's minute by minute, second by second, and it's continuously updating. I think about Amazon, right? And the way that Amazon sales works. Amazon, as you know, sells hundreds of thousands, maybe even millions of products daily. Okay. And out of those hundreds of thousands and sometimes millions of transactions on a daily basis, this system, the transaction system, needs to update regularly. So what happens after the data is collected? The data is processed in really one of two ways. We call it's either processed through what we call batch processing or real-time processing. In the example of Amazon, they use real-time processing. It processes almost instantaneously, right? As soon as you make that purchase, there's a charge, right? And it goes through real time. Another way that transaction processing data is processed is through what we call batch processing. And the example I'll give here is a gas station. You go to fill up your vehicle with fuel and you pay at the pump. You'll notice that that transaction doesn't hit your bank account until the next day. Well, why is that? Or why would it say processing on your bank's application for a full 24 hours? That's because the gas station uses what we call batch processing. They collect all of the transactions that happen during that day and they batch it out, meaning they process all of it in batches. So, and I'm going to talk about that here next. So in batch processing, essentially the way it works, in a simplistic way, is we're taking all of the transactions that happen throughout the day and we're processing them at the end of the day. Yep. So you gather all the transactions that occurred throughout the day and you process them in a batch, right? This process is used by a lot of small businesses, medium-sized businesses throughout the world. It's easy to use, it's very efficient, it's scalable, and it's helps to ensure the quality of the data, right? There's a lot less errors because we're only doing the process once for the day rather than doing it every second. If you're processing data every second, transactions every second, there's a risk for error. There's a possibility for error. But if you're processing the transactions once throughout the day, there's a lot less possibility for error. This flow chart, if you will, really puts batch processing into perspective. We see the transaction. There's a record of the transaction that gets created. There's an update to that transaction that's adding that transaction to the batch. Then we schedule the batch for processing, usually at 11:59 p.m. that day. Okay. Once the 11:59 p.m. rolls, the batch gets processed and the data gets stored into the database. And so the next morning, when the management goes in to see the sales from the previous day, based off of the batch report, they're able to see that in relative real time. So that's batch processing. When it comes to the real-time processing that I just mentioned, the transaction is processed as it occurs, and it requires the company to have a high processing capability. Okay, so transaction occurs, database updated immediately. Whereas in batch processing, transaction occurs, it gets posted, the post moves to a batch, the batch gets processed, and then updates the database. So real-time processing is immediate, whereas batch processing, there's a few steps involved. So these two infographics really help to show you the difference. Now, of course, the software helps us to govern those types of transactions, right? We all use software of a sort to help us to manage the information, help us to govern the information. The software is the interface. It's the interface that management uses to help us to identify and analyze the information. Right? That's what software does. So it uses the components to interface, extrapolate, and analyze the data. Now, of course, software is created by using programming languages like SQL, JavaScript, Java, HTML, Python, etc. C++, Go, Scala, you name it. These are all examples of programming language. The programming language is essentially code, strings of code that create the software. As I had mentioned, these are the types of programming languages currently used. Most common ones would probably, of course, be HTML, C++, and JavaScript. Those are probably the most commonly used programming softwares. But of course, as we're advancing in artificial intelligence, this is becoming a lot easier to do, because artificial intelligence is assisting us in software programming, among other things. So the software itself can be talked about as being a system, right, of different components put together. One of the most common database softwares I think about that come to mind would be would be Power BI or Tableau. Okay, so Power BI has a lot of components that are interfaced with other softwares, with other databases, etc. I can extrapolate data in Excel through Power BI. And Power BI will help me to visualize through a dashboard the data that I'm looking at in Excel. So software is specialized to run on a computer or other software. And the platform, of course, helps to coordinate these activities. In other words, the platform could be Microsoft's Windows or Macintosh's Apple software. Those are your platforms. You got Microsoft and you got Apple. And you might have, to some degree, Google or Linux. So you have those platforms. The software is built on those platforms. They're specialized to run on those platforms. So that's the way I want you to think about it. Okay, some examples. So for database management, we got things like SQL Server, Oracle, Microsoft Access. Yeah, all great examples. I would also include Power BI and Tableau in there. For communication softwares, of course, we have email, file transfer protocol clients, etc. That could also include your VPN. And then we have the utility programs. So utility programs act more like the back end that you might not necessarily see. That would include things like your network manager, antivirus software, backup software, disk cleaners, file compression, etc. I consider those like the back end. Yeah. So application software, the things that you're most familiar with, applications or apps as they're commonly known, would include things like Microsoft Word, Excel, PowerPoint, Outlook, Power BI, Zoom, PowerPoint, I mentioned PowerPoint, Teams, etc. These are all applications. You know what applications are, but think of the software as being an application. When it comes to the development of software or how to acquire software, it's important to consider what your options are. So oftentimes, as an individual, we typically purchase the software from a vendor. Okay, very common. Yep, you might go out to an app store, or you might go directly to the software supplier and purchase software from them. Yeah, we call that third party. Alternatively, companies might develop their own software for what we call in-house development. These are custom made just for the company. We call it in-house development. So there's of course risks for both in-house development and for third-party purchases, but let's talk about third-party purchases first. Yeah, copyright infringement, there's always a risk there. If you are purchasing it from the software from a third party, they might not necessarily have the copyright licensing in place. So very important to check that first before you make a purchase decision. Data breaches is always a huge risk with third-party vendors, because if a third-party vendor gets hacked, you have the potential to lose your data through that hack. Disruptions is another one. If the something happens to the third party, you might lose access to that use of that software. And of course, updates. Sometimes third-party vendors don't push updates as frequently as the software developer does. When it comes to in-house, yeah, a couple of risks to be aware of. Budgeting. It takes a lot of resources to develop your own software in-house. It can be very expensive. Scheduling, of course. It takes a long time to develop software. Technical specifications. It's very clear, very important to have a clear pathway when it comes to developing in-house software up front on the technical specs. Uh, More risk. One could be the external market. Sometimes we develop our own softwares and then we find something outside that's better, easier to use. Or another one is fraud. Yeah, sometimes coders might act unethically, and so if that happens, writing the code into the software for fraudulent reasons could grant access to what we call backdoor access, where individuals are unauthorized gain access to the system. So these are all risks to be aware of as you're making a decision whether to purchase something off the shelf through a third party vendor or to develop your own software in house. In today's age, of course, a lot of things that we do are what we call cloud computing. This is the alternative to storing data on a hard drive within a computer or on a digital drive within a computer. Cloud computing allows the storage of information to be virtuals, meaning you can access it from any device, anywhere, anytime. All right, that's the benefit behind cloud computing. Pretty much anything internet based is considered cloud computing. Uh, Even running software applications through a website like Office 365 is run through the internet, so that could be considered cloud computing. And then, of course, any other services. The idea behind this is that it is accessible from anywhere, very easy to use, uh, and that the cost of the cloud computing, the benefit to the cost is that everything's maintained virtually, right? Uh, so things to consider when you're looking at things like cloud computing. A couple of different types of environments for cloud computing. One's called a private cloud. This is a network where only authorized individuals have access to it, and it is very limited to what access it has outside of that network. It's customizable and highly secure. A public cloud is available the to the public through a provider. An example of a public cloud might be a government agency that provides information to the public through their server. It's secure, but it for example, it requires a login, a user login and password. However, the access is through a web browser. So what that means is that it's not terribly secure. There's risk, right? There's risk to being hacked. And of course, the advantages here is that it's readily available and at a relatively low cost. Most organizations use what we call a hybrid cloud. This is a mix of both public and private. On the private side, it's for the company employees only, basically. And on the public side, it's where the clients, customers, provide their username and password, log in to the environment for their respective transactions. Of course, yeah, it's increased flexibility. The cost is relatively moderate and security is relatively moderate because of that private public component. When it comes to cloud computing, uh, as I just discussed, there's the three different types of clouds. There's private, public, and mixed or hybrid. But cloud computing can also be provided as a service. And we see this currently when we look at third-party providers. So software as a service is one of those. Microsoft commonly provides their applications as a service to an enterprise like a university, for example. UMGC uses Microsoft Office 365. So, and that is provided by Microsoft. Of course, the university pays for it to Microsoft, but it's provided as a service. Another example would be Tableau, Power BI, which is actually a part of Microsoft 365. Other examples would include things like Google Drive, Salesforce, Slack, etc. That's software as a service. And then, of course, we have what's called platform as a service. This is where customers are provided platforms for that software development for it to be delivered remotely. The developers, of course, have access to a lot of tools through a platform as a service. Examples of this would be the Google App Engine, OpenShift, Apache, Stratos, and then of course there's a lot of other ones out there as well. In fact, Microsoft has their own platform as a service. And then, of course, other developers that are developing things like other computer applications or games. Unity is one of those platforms as a service. When it comes to infrastructure as a service, this is where customers are provided with self-service computers, networking, storage, and operating through a virtual environment. Most commonly used in this space is Amazon Web Service and Microsoft Azure. Very, very commonly used. And then, of course, Rackspace is another one. So when it comes to these services, there's inherent risk involved that you need to be aware of that could be a risk to the business, right? So software as a service through cloud computing has risks related to them. So when it comes to reliability, customer loses internet connectivity, that's a risk. Provider has unreliable in providing the software, that's a risk. When it comes to privacy, if there's a hack involved, there's a possibility of losing customer data. And of course, related to that hack would be security. Sometimes the customer could have a potential financial loss due to that hack. So of course, that would be a security risk. We see a lot of potential for technology as startups. So oftentimes startup companies, they don't have a whole lot of capital to their avail. So without that capital, it's difficult for them to launch a successful product that because it requires a lot of updates, it requires a lot of support. So technology startups, you have to be somewhat weary of them. However, as they continue forward and gain stability, they become better. So here are a couple of examples of softwares used by small businesses that are relatively inexpensive, uh, that support the business as it's starting up. Square for payment processing. We see this a lot with mobile food trucks and other small businesses. Square, it provides the hardware, which is where the customer swipes their card. It also provides the software for the payment process. But of course, it's important to distinguish. Square is not a payment processor. The processor is going to be either Visa or Discover, right? It's not going to be Square. Square is not the process, or they provide the software and the hardware for payment processing. When it comes to data processing, a lot of small businesses use Excel. They use Excel for a wide range of reasons. Oftentimes, it's to track things like sales and analyzer sales, inventory, etc. They might use Microsoft Access for storing data, especially if they have it included in their Microsoft package, because the cost of storing the data is a lot lower in Access. They probably utilize what we call the Internet of Things. Internet of Things, of course, involves a lot of different things. I like to think about things that are connected to your home network. You might have your Amazon device. You might have lights, sound. You might have a Ring video doorbell system, security cameras, etc. These are all connected to your home network. Collectively, you would call those the Internet of Things. And of course, a lot of small businesses use QuickBooks for their accounting because of the ease of use and for getting started in that area for small business. So here we see an example of an Excel spreadsheet. Again, a lot of different types of data could go in here and be analyzed, sorted. Under that data tab, which I really enjoy, you can analyze the data in a lot of different ways. It's very fascinating with a level of integration that Excel has now. Throughout all of that, in understanding how small businesses start up and the types of data and tools that they use, it's important to understand the risks associated with it. So a lot of small startup companies and small businesses, they have a couple of different levels of risk that we look at. Startups have few resources, right? A startup company doesn't have a whole lot of capital, so they might not have a higher level of security to protect customers' data that a large corporation would. So when it comes to that, we look at things like compensating controls, which be used to reduce the risk when more expensive or complex controls are missing. So how do we mitigate that risk? One, of course, is the segregation of duties. And I'm sure you learned this in an earlier accounting class where we probably discussed the fraud triangle and the importance of separating tasks. For example, the person writing the checks for the business should not be the same person receiving payment from customers, right? Because that creates conflict within the business. It provides an opportunity for theft or fraud. So in order to mitigate things like that, we separate duties and responsibilities. However, in a small business, that can be very difficult, especially if there's only a few employees. So it's important that in the business structure to have some type of segregation of duties. Another mitigation strategy is physical access. The individuals counting the cash should not be the same individuals receiving the cash. You see, uh, physical access, having things separated is really, really important. This helps us to prevent other unauthorized individuals from gaining access to our assets, right? Other examples would include things like buildings, computers, hard drives, inventory, uh, other types of lockups, security cameras, you name it, right? This level of focus is important because you need to really understand who has access to your physical assets and why. And make sure that there's a policy in place to who has access and how to control that access. And another mitigation strategy I like to look at is logical access. Sometimes it goes without saying, but we want to prevent people from accessing our network, workstation, database, or other applications that shouldn't have access to it. Right? So oftentimes small company might not be able to afford to implement a biometric system for accessing the network. Right? They don't have a fingerprint reader because it could be expensive. They don't have a facial recognition software because that could be expensive. So they might have something like dual factor authentication, right? You enter the passcode in, and then you go to your cell phone and you have to enter another code in to gain access, dual factor authentication. That's relatively inexpensive and easy to do. So a small business might use that. But as they gain additional resources, they might advance their access controls. So we talked about the security aspect of things. We talked about the software aspect of things. Now I want to talk about growth. Businesses typically grow in a couple of different ways, but the primary two ways that the business grows is organically or if they acquire another company. Very typical. Organic growth implies that they're going to use their own resources to increase their sales, increase their number of customers, and ultimately their market share. That's organic growth. They're using their own resources. Acquisition-based growth is the company's going to purchase another company, right? Because it would allow them to grow more quickly through mergers and acquisitions. And I can give you a couple of different examples here. Organic growth, I like to think of companies that started small and grew quickly through their own means. An example I could give here, there's so many of them. I like grocery stores, so we can think of a giant grocery store chain. They started locally in the DMV area, and then they started opening new grocery stores, and they grew organically, right? They didn't acquire or merge with any other grocery store. They just did their own thing. And so that would be my example of organic growth. When it comes to acquisitions, I like to think about there's a couple of different examples I can give here. In the hotel business, there's been a lot of mergers and acquisitions that have occurred. For example, Choice Hotels acquired a lot of different brands. Most notably, they had acquired Comfort Hotels, they acquired Cambria Hotels, they acquired a couple of other brands that you're probably familiar with. International Hotel Group is another one that acquired, and they acquired uh, Holiday Inn Express, and several other brands. So how did they grow? They grew through acquisition. This nice infographic tells us the growth of either through merger or acquisition. A merger, of course, is a combination of two separate companies into one, and the acquisition is one purchasing another one. The acquiring party, of course, is the one that ultimately gains full control over the company, whereas a merger, depending on the structure of the merger, depends on who has control over the new company. Okay, so shifting gears a little bit from the growth of the companies or how companies grow, I want to take a look at how systems integrate. And thinking about the mergers and acquisitions, companies have their own ways of doing things. You got two different companies that are coming together, whether it be through a merger or through acquisition. Two different systems. So how do we integrate, combine these two totally different systems into one? Well, we do that through this process called system integration to bring them together, have them function cohesively. Companies use different databases and they got to figure out whose database they're going to use, or are they going to do a separate third party database, or how are they going to structure it? So I'm going to give you a real life example here. I worked for a company in the biotech space that acquired a competing company in the biotech space. And through that acquisition, they wanted me to help them to merge their accounting together. So in merging the accounting together, I looked at the two separate companies. Luckily, they were both using QuickBooks, so that part was good. But I had to figure out how am I going to get this company's QuickBooks and this company's QuickBooks into one. So I looked at a lot of different strategies and how to do that, and ultimately decided on um, uh, based off of the number of transactions, which book would be what I called the parent book, right? To bring the two companies within one accounting system. That's just an example of a system integration that I performed. So the process, we call it lift and shift and then integrate. Lifting, moving, and then shifting, moving it over to is the acquisition company moves the acquired uh, company's systems, physically moving them servers into one. Uh, and then, of course, a similar process when it comes to the integration for the software. So when it comes to the integration, an immediate integration is immediately converting the existing data, one being retired, and then migrating it into an entirely new system. Yeah, this process is very efficient. It takes a lot of time and a lot of effort. It usually involves a lot of people working in once. When it comes to the system configurations, it's really important to understand how different systems talk to each other, how different databases talk to each other. And sometimes they don't, and that makes it really complex. I'll give you another example from a previous life. One time I worked for a company that had a retail operation. They also had a hotel operation, and they used two different databases that did not talk to each other. And so it was very difficult because in accounting, especially, we need to see the data in one place, not pulling it from different databases and then figure out a way to combine it. That makes it very difficult. So ultimately, what I did was I had to create what's called a configuration channel for the two systems to integrate with QuickBooks, right? So it's a very complex system, but it worked. And so the point that I'm trying to make here is that you have to figure out ways to get different databases to communicate with each other, yeah, to make the process a little bit more seamless. And one way to do that is called a centralized system. A centralized system, just as the name implies, has a central server where the data is stored and it's collected from different computers on the same network. Yep. That's the idea behind a centralized system. It has its advantages and disadvantages, of course. It's pretty easy to establish. It's almost as simple as creating a network, a whole network. Yeah. Multiple devices, same Wi-Fi, basically. Yeah. It's a way of thinking about it. The central computer and a central point, a central server located, it's secure, locked up. The data is easily authorized by the different users. It's pretty continuous and it's relatively low cost. For low cost of maintenance, I should say. It's kind of expensive to install. Disadvantages. The risk of disruption. If something happens to that central server, you have to run the potential of losing a lot of data. Bottlenecks due to traffic. And then, of course, if you have multiple users in different locations, might be difficult for them to access that centralized server. Depending on the size of the organization, they might use what we call a decentralized system. Just as the name implies, there are primary servers scattered throughout the system that are being accessed at multiple points from multiple users. The decentralized system, as the name implies, not all the users are accessing from the same access point. There's multiple access points scattered throughout. So large organization like a defense contractor might use a decentralized system. Advantages, disadvantages. The great things about a decentralized system is that it's strong processing, right? Without having a central location, it's easier, faster, a lot less processing time. It's highly responsive. Yeah. So if one part of the network goes down, the whole network doesn't go down, it stays operating. Disadvantages. Increased security risk. Because there's multiple locations, if they're not all being watched 24/7, that could be problematic. Cost of installing multiple locations, of course, is going to be higher. A few more advantages of it. Yeah, reduce bottlenecks. So there's a lot less processing time. And and as I had mentioned, if one part of the system goes down, the rest of it can still operate. And the third type of system is called a distributed system. So as the name implies, it kind of works like a decentralized system, but it takes it one step further. All the systems are directly connected to one each another, and acts more like a nucleus. The process and the database are being distributed across several business locations, but they all have access to each other. That's it. Distributed system. Couple of good things about the distributed system. Communication across users is increased because of the direct connectivity. Real-time transaction data is easily available and ready for all users to observe and process. Uh, there's a reduction or elimination in some cases of expensive central systems. Uh, on the disadvantages side, though, it's the most expensive option, right? Because it's got very high maintenance costs because you have so many different locations, and it'd be very difficult to implement. As the name implies, very complex. Other advantages of using it, though, would include growth and scalability. As the company grows, as the system grows as well. And by having multiple areas, if there's a system failure, the whole network will still maintain operation. So let's talk a moment, since we're talking about integration, we're talking about the three structures. I want to talk about a solution for systems integration. Because you have so many different databases that don't necessarily talk to each other and they have different functions, it's important to identify databases that meet the needs of the company and meet the needs of all the functional areas within the company. And the best way to do this is through what we call an ERP, or Enterprise Resource Planning System. This helps us to assess the needs of the company and identify the related applications that the company needs in order to provide the system service to each functional area within the company. An example I'll give you here. QuickBooks has a couple of different what we call add-on features. QuickBooks is a very simple software used by most small and medium-sized businesses in the United States. What a lot of people don't know is that it has a lot more capability beyond just the accounting work. It has the ability to also manage inventory. The inventory management component of QuickBooks is an add-on that updates based off of whatever system, whether it be perpetual or periodic, updates the inventory. So the QuickBooks feature, the QuickBooks being the software, and of course the feature being the inventory management, together we call it Enterprise Resource Planning, ERP. And the reason why we call it ERP is because the business has a need for managing inventory. And as that need is there, we're adding on that service into our primary database, our QuickBooks. So it's just one example of many. Benefits of using an ERP. It's complex and it can be expensive depending on which one you're using, but it's efficient. Once you've implemented it and you've gotten past that initial expense, the future benefits are improved data, transparency and quality, future cost savings, increased business efficiency, quality improvement, and of course, automation. So a couple of different models and features for ERPs. Every ERP has an ERP module. And this goes back to my QuickBooks being the ERP and the module being the inventory management. Within each ERP system module, there's various business processes and features. with specific capabilities. ERP modules can include things like a financial module, a CRM, an SCM, sales management, production, and HRM. Going back to the QuickBooks example, inventory management being one of the modules, but then of course, which could include, I guess we'll say production module here. And you can add on something like payroll, which will be a part of human resources management. And you can even do an add-on for a CRM, a Salesforce add-on, into QuickBooks integration. So it just kind of gives you an example of how it comes together. So you can see that the individual modules have functions within those modules, right? And there's a lot of cohesion involved. So implementing an ERP is very complex. It's very expensive, but if you do it correctly up front, it'll save you many, many years into the future. Yeah, it's a high process functioning system that a lot of medium and large size businesses use. Vendor, when it comes to selecting a vendor for your ERP, it's really important that you compare the benefits and solutions that they provide on a side-by-side basis. Don't always go with the cheapest one, because the cheapest one may not always be the best, right? So when you are selecting it, there's a couple things you could look at. One is out of the box, works off the shelf right away, nice and simple. I prefer the configurable and customizable ones. Having those add-ons based off the company's needs is really, really important. You want something that's going to work for the business, right? So something that you can customize is really, really important. And of course, when you're looking at the implementation, think about those different type of costs. It adds up, right? Licensing fees, customization, that's the different modules. If there's any hardware involved, like a rack for the server, etc., any type of consultancy and training fees, and if you're looking at the time used by the employees. So just be very aware of the different types of costs that are associated with it. Okay, that concludes our discussion on software and systems. If you have any comments, questions, or concerns, you can always email me, call me, or set up office hours. I'm here for you all the time, so I thank you very much for your time today. Have a wonderful rest of your day.